Hi, Assalamualaikum warahmatullahi wabarakatuh. Now in this video, I'm going to solve example 3.2 here using the p-value approach. Okay, so we're going to solve this example using the p-value approach. Okay, right, so now let's talk about the important information that you can generate based on this example. The first one here is this statement refers to the null hypothesis statement, and this is the sample of 30 IT executives, which is the value of small n, and this is the value of x bar. So alpha 0.05 is the significance level, and we are going to test the claim that IT executives earn more than 42,000 a year. So this statement here is the alternative statement, alternative hypothesis. Now assume the population is normal and the population standard deviation is known. So this is sigma. So when the population standard deviation is known, you need to resort to the formula that will use the standard normal distribution as a reference. Okay, so let's go back to this part here. You can see that when you have data that comes from normal population with mean mu and variance here is assumed known, so you're going to use this statistical test. So when using this statistical test, later on you will have to refer to the standard normal distribution table for finding the critical value and also to find the p-value, for example. Yeah. Okay. Okay, so now we are going to apply the p-value approach. If you want to know what is the p-value approach, well, I have said something about the p-value approach in the previous slide, which is this slide. So there are 5 steps altogether, 1, 2, 3, 4, 5, and you will see that for the first 2 steps here, it is similar to the traditional approach, and the third step is a bit different, but the fourth and fifth step here is more or less similar to the idea of traditional approach. Okay, so I'm going to illustrate this p-value approach in this given example here. Okay, so the first step is to write down the hypothesis statement. The hypothesis statement is H null, and mu is at most. So when you talk about at most, that means the highest the salary can be is 42,000, but it can go lower than that. So that's the meaning of at most. Therefore, we have mu can be less than or equal to 42,000. So next is the alternative statement. Okay, so next one is the alternative statement. So here we have mu greater than 42,000. So there you go. Our hypothesis statements are done. Now we move on to calculating the test statistic. And again, because sigma is known, so sigma is known, the value is 5230, which is equal to 5230. Therefore, the statistical test that we have to use is the Z statistical test, and the formula given here is x bar minus mu. Over here we have sigma, this is square root of n. And we're just going to apply the values. We're just going to substitute the values, which is going to be, this is x bar, 43,260, 43,260, and the value of mu here comes from this statement, because we can say that mu is equal to or less than 42,000. So when you have the term equality, when you have the equal sign, that means you can replace mu with 42,000. So here we go, we have 42,000. Next, sigma is 5230, and that is going to be over square root of 30. So 30 here is the sample size, and once you punch in the values into your calculator, you will get the answer is going to be 1.32 This is by taking 2 decimal places. Okay, so you can see that the first step and the second step are similar to the traditional approach. Now let's move on to the third step. So in the third step here, we are going to consider what is the p-value. Okay, so in the third step is we are going to find what is the p-value. So what is the p-value? So the p-value is the area that refers to the extreme side of it. For example, if I sketch this simple diagram here of a standard normal distribution, the middle part here, so this point here, is going to be 0. And we know that the values to the right here is going to be positive values, and the values to the left here are all negative values. Yep. So where is the 1.32? Where is the position of 1.32? And since this is a positive value, we know that 1.32 is going to be somewhere here, and we are looking to find the p-value here is the probability of this area from 1.32 to the right. So this area we wanted to find what is the area here. Okay, and so we are going to refer to the standard normal distribution table. Right, so here is the standard normal distribution table, and we are interested to find the area of 1.32 to the right of that. Okay, so we're looking to find what's the area from 1.32 to the right of this distribution. So this is at 0.0, and so this is the value of z. So you have to refer to this part here, this part. Okay, so 1.3 is somewhere here, so 1.3 is plus 0.02, so you will get 1.32. So the value or the area is 0.0934. So the area here, is equal to 0.0934. So this is the p-value. Okay, right, so based on that, we can see that the p-value is, just going to write down the value. The p-value is equal to 0.0934. Now on the fourth step, we are going to compare the p-value with alpha value. So alpha is a significance level, so we are going to compare p-value with the significance value, which is alpha. Yeah, so here alpha is equal to 0.05. based on the question given here, alpha is 0.05, and therefore since p-value is greater than alpha, you can see that 0.0934 is greater than alpha, then we won't be able to reject the null hypothesis. Okay, p-value is greater than alpha, or we can say that 0.0934 greater than 0.05. Therefore, the null hypothesis is unable to be rejected. Okay, it's unable to be rejected. So you can see that if I want to compare the area of this one, p-value with alpha, so if this is the area of 0.0934, alpha is just 0.05. that means alpha is somewhere here. So this is the value of alpha. The critical region is this one, and so you can see that the p-value here is greater than alpha, and that's why we will not be able to reject H null. Okay, so the fifth step is going to conclude. So we're going to conclude the whole process here. And remember, when you want to conclude the hypothesis testing procedure, what you can do is you can talk about the alternative statement. So since we cannot reject the null hypothesis, Therefore, we will say that there is not enough evidence to support this statement, to support the alternative statement, to say that the average salary of IT executives is more than 42,000 ringgit Malaysia a year. Okay, right. I think that's all for now. Thank you very much for watching.